Hello guys, we are going to talk about connected components in a graph today. We will be analyzing an undirected graph. This is the sample graph which we will be working with. Now connected components, this is a graph which has three connected components. First connected component is having vertices 0, 1 and 2. Since the graph is undirected, we don't have any arrows. We don't have any direction given to this graph. It is also an unweighted graph since the edges don't carry a weight. Connected component number 2 is connecting vertices 3 and 4, and connected component 3 does not connect to any other vertex. We will be coding it out using an adjacency matrix representation. So let's start the code. We are writing code in order to print the number of connected components. So I will start by writing hash include iostream. I'll use the standard namespace. Since I am using the adjacency matrix representation, I have 6 vertices. I am initializing it all to 0. I will make use of a function called addEdge. I'll pass 3 parameters to it. The graph representation G. Then we are going to look at there's an edge from 0 to 1 as well as from 1 to 0. Our next call sets up an edge from 0 to 2. So I will go ahead and write down 0 to 2. Then I'm going to go ahead and set up another edge from 3 to 4. So another call from 3 to 4. I will now code out the addEdge function. I'm passing it the graph representation. Adjacency matrix is what we are planning to use here. Integers u and v representing the vertices. Now since it is an undirected graph, gu and vu are both set to 1. It simply means if there is an edge from vertex 0 to 1, there also exists an edge from vertex 1 to 0. I will take a variable count. This holds the total number of connected components. I will also go ahead and take a boolean array visited. Now the number of vertices are 6, not 5 here. I'll initialize them to false. All of them are 0 and 0 means false. We will be running a loop from I0 till I is less than 6, I++. If we encounter a vertex which we have not visited, so this would give me false. In order to get it inside the loop, I'm going to put a negation symbol here. So what I will be doing is I'll be calling DFS. I'll be sending the graph. I becomes the source vertex and visited happens to be the boolean array which tells us how many vertices we have visited so far. And in the end I will print out the count. Let's now code out the DFS function. It receives as a parameter the representation of the graph, the source vertex indicated by S, and the boolean visited array. I will go ahead and set the source vertex as visited. We will now run a loop for all the vertices adjacent to the source vertex. So I will write down if g of si. The reason I'm writing if g of si is if there exists an edge from source to this vertex, then it will be 1, and you have not visited that edge so far. So let's do a DFS again on this graph G with I as the source vertex, and I'm also passing it the information of all visited vertices. Let's try to compile it. So G++ connected components, we got lucky here, and if we run it, we get the number of connected components as 3. Now this is a very common question asked in interviews as well as many online coding competitions. I hope it was helpful. Take care and be safe. Thank you.